Welcome back, chemistry fans. Okay, we are going to do the warm up for today that is going to get you prepared for this brand new unit. I know that the warm up actually says the wrong date, and that's because we're behind with the snow day. So let's jump right into it. Let me share my screen and we will get started on this. Okay, first question it is asking us is to visit our old friend, the mole map. So you are going to have to remember that in your fabulous mole map, there is a way to convert from grams into moles. You will have to do this multiple times in this unit. So this process is a division. If we were going the other way, moles, it would be multiplication. Go into your cheat sheets and let's make sure that you remember how to do that process. Just a second. Okay. So if I am given 50 grams, I'm going to have to then, as you may try and remember here, going to have to divide by the molar mass. So let's do that process. So I've got 50 on top. The weight of copper is roughly 64. The weight of sulfur is roughly 32. The weight of the four oxygens, 16 times 4, that's another 64. So if I add up all of those weights, 64 plus 32, I get 160. So 50 divided by 160 is 0.31. 0.31 what? Moles. Okay, so that is a skill that you're going to have to reacquaint yourself with because soon as we start in this new unit talking about molarity, it's quickly going to ask you to convert grams into moles so that you can solve for this new formula. Part of the other score, and that you're going to have to remember is how to convert milliliters into liters. There are 1,000 milliliters in a liter, so all you're going to have to do is divide by 1,000. So this answer becomes 8.450 liters. Now, in that same mole map, there was another direction that you could go. You could go out here to liters. And so trying to get you to recognize that this is part of that mole map and that you have the ability to go from liters into moles. That is a division process. And then moles out to grams, that is a multiplication process. So the 12.4 divided by 22.4, and that gives us 0.55 moles. And then we would multiply that times the weight of carbon dioxide, which is 44. Added up, carbon is 12, and the two oxygens are 32. If you do that, you get 24.4 grams. Okay. Number 4 is more on this unit 7, the antibonding. So we had this hybridization um, hybridization where we are learning where the electrons go in an orbital diagram. However, in this one, it looked a little different with these hexagons. And what we had to understand is that there are bonds, and they're the ones where they share electrons. But then if there are too many electrons in that same area, they call them antibonds, and they repel. So an antibond is where we have too many electrons in the same area of the atom, and they repel one another. So they don't allow any kind of sharing of the electrons, bonding between the two atoms. All right, and then the last one. What is the hybridization and bonding order of PF6? Well, the first element always goes in the middle, and then it has, in this case, 6 halogens. They're all going to have single bonds around it. This is the most bonds that you can have around a central atom. And in this scenario, what we have to understand is that there are 6 ligands. There won't be any extra electrons, so there's 6 ligands. So each one of those represents a different overlap of electrons. So that would be S for the first one. That fills it because it only has one blank. Then there are 3 Ps, and then there'd be 2 Ds. So that'd be 1, 2, 3, 4, 5, 6, representing the 6 single bonds that are around the phosphorus. But we combine all those and we write this as sp3d2. Now, the bond order, you take those same number of ligands and you divide it by the same number of bonding regions, bonding locations, and we get 1. And basically, what that is saying, the bond order is the average number of bonds for each one of those areas. And since they're all single bonds, it ends up being 1. All right, this is everything that I wish to share with you. Thank you very much. And I hope that this refreshes your memory a little bit and helps get you started on our new unit dealing with molarity. Talk to you again soon. Bye-bye.